Hi friends, in this video we are going to talk about electrochemistry. Now, what is electrochemistry? Electrochemistry is nothing but a study of production of electricity from energy released during the spontaneous chemical reaction and making use of this electrical energy to carry out a non-spontaneous chemical reaction to happen. A large number of metals like sodium hydroxide, chloride, fluorine are all being produced by this electrochemical method. So it holds very important place in this chemistry. So electrochemical cell is nothing but a device in which a chemical energy of a redox reaction is converted into an electrical energy, while an electrolytic cell is opposite, reverse of this. So electrochemical cell is nothing but a chemical energy which is used to convert the electrical energy, and electrolytic cell is nothing but electrical energy which is converted into a chemical energy. So why we want to talk about this electrochemistry is because the reaction carried out electrochemically can be energy efficient and less polluting, and therefore the study of electrochemistry is important for creating a new technology and eco-friendly. Now, what is a redox reaction? The redox reaction is nothing but a reaction where both oxidation and reduction takes place. What is a galvanic cell? Galvanic cell is an electrochemical cell. So it is called as either galvanic cell or voltaic cell. The important example of this galvanic cell is the Daniell cell. So while explaining the Daniell cell itself, we can see what is galvanic cell. So it consists of two half cell. Here, the first half cell, the zinc rod is dipped in the zinc sulfate solution, and the copper rod is dipped in the copper sulfate solution. So this creates a two half cell which is being connected with the electrical circuit and a salt bridge. The combination in which the electrode dipped into the solution of its own salt is called as a half cell. Okay, so the oxidation takes place in the anode and the reduction takes place in the cathode. So what is an oxidation? Oxidation is nothing but loss of electron. So here zinc loses electron and therefore it comes as acts as an anode, and the copper gains electron to form a metal and therefore it acts as a cathode. So this is the overall reaction where the two half cells are called as a redox couple. So this Daniell cell will generate 1.1 volt from this redox reaction. It will from this redox reaction when the concentration of zinc 2 plus and the concentration of copper 2 plus is considered to be as 1 mole per decimeter cube. So at this concentration, this Daniell cell is expected to produce 1.1 volt electricity. Now, what is the use of this salt bridge? Salt bridge is nothing but U-tube. This U-tube consists of an electrolyte like KCl, potassium nitrate, ammonium chloride, and it will be mixed with a gel-like substance like gelatin or agar-agar. It is very important for the cell because it connects the two half cell and completes the circuit, and it maintains the electrical neutrality by preventing the diffusion of the ions between the half cell. So what happens when an external opposite potential is applied to a galvanic cell? So when I'm going to apply an external opposite potential in the galvanic cell, slowly if I'm going to increase the potential, it will just acts like a electrochemical cell till it reaches the 1.1 volt. So after reaching 1.1 volt, it just stops the reaction. And if I'm going to increase again the external potential, then it will act as a electrolytic cell. So now we'll study all these in three cases. The first case is, first I'm going to apply external potential in the opposite direction of a galvanic cell. So what happens? It will be lesser than the potential of the Daniell cell. So here what happens? The electrons will be flowing from anode to cathode, and the current will be flowing from cathode to anode. So slowly if I increase the potential, it reaches 1.1 volt. As it reaches 1.1 volt, what happens is it will stop the reaction. That is, no electron or current flow will happen. So if I'm going to again increase the potential slowly, so what happens here? The reaction will get reversed. That is, the electron flow will be from the cathode to anode, and the current flow will be from anode to cathode. And what happens? It will become like a electrolytic cell. Now the zinc was deposited at the zinc electrode, and the copper will be deposited at the copper electrode. So these are the three cases if I am going to apply an external potential. So now we are going to learn about the certain important terms of the electrochemistry. The first one is electrode potential. So at each electrode-electrolyte interface, the metal ion in the solution will have a tendency to leave the electrolyte and deposit on the electrode, making it to be very much positive. Similarly, the metal in the electrode will release electrons and make the electrode to be negative. So as a result, there will be a separation of a charge in the electrode. So depending on the net charge at equilibrium, the electrode may be either positive or negatively charged with respect to the solution. So the potential difference developed between the electrode and the electrolyte is called as the electrode potential. Now, what is the standard potential? Standard potential is nothing but when electrode potential is under a unit concentration of all species, then in the half cell, then it is called a standard electrode potential. So, as I told you, if I'm going to take the Daniell cell concentration of zinc ion or the concentration of copper ion, if I'm going to take it in 1 mole per decimeter cube, then it is considered as a standard electrode potential. Okay. So as an IUPAC convention, the electrode potential, standard electrode potential is also called as a standard reduction potential. So we always talk about the reduction potential only. So if I'm going to talk about the potential of a copper, we usually talk like E naught of copper plus 2 to copper, no, and that will be like plus 0.34 volt, right? So we usually talk only about the reduction potential. So according to IUPAC, the standard reduction potential is called as a standard electrode potential. So what about this oxidation potential? If I'm going to have an oxidation potential, the values will be same, but only the charge will get differed. Okay, so the oxidation potential of a copper will be like this. So Cu2 plus, so it will be like minus 0.34 volt. So only the charge will be differed. So what is a cell potential? In a Daniell or a galvanic cell, the half cell in which the oxidation takes place is called as anode, and the half cell in which the reduction takes place is called as cathode. Anode will always be negatively charged and cathode will be always positively charged. So there exists a potential difference between these two electrodes. When a switch is in this position, the electron flow will be from the anode to the cathode, and the current flow will be in the opposite direction. So potential difference between these two half cell is called the cell potential, and it is being measured in volt. So the cell potential is nothing but E cathode minus E anode, the potential difference between the two half cell. Since it is going to be a reduction potential, we are going to take cathode first and then the anode. Okay. What is the EMF of the cell? So it is also a potential difference when no current is drawn from the system. So it is also measured in volts. So EMF is equal to reduction potential of a cathode minus reduction potential of an anode. So it will depend on three conditions, which is the nature of the metal or ion, and the concentration of the electrolyte used, and the temperature. I hope you all understood. Thank you.